Welcome students. Today we will discuss Equilibrium chapter. You all must be acquainted with well-known word equilibrium. The term equilibrium in physical sense is defined as no change of state of the body. The state of the body can be either the state of rest or the state of uniform motion. In this unit, we will talk about concept of equilibrium, law of chemical equilibrium and equilibrium constant, law of mass action and its application, and Lee-Satirius principle and its application. Equilibrium is a state in which there are no noticeable changes occur. It is achieved when the rates of forward and reverse reactions are equal. Most of the reactions are reversible in nature, that means they occur in both the directions. At the start of reversible process containing only reactants, the reaction proceeds towards the formation of products. As soon as some product molecules are formed, the reverse process also begins to take place and the reactant molecules are formed from product molecules. That means chemical equilibrium is achieved when the rate of the forward and reverse reactions is equal and the concentration of the reactants and products remains constant. Chemical equilibrium are stable and dynamic in nature. Chemical equilibrium is observed or it happens inside our body. When the body reacts with calcium ions that are found in the kidney form calcium oxalate crystal, and when the number of calcium ions increases, the equilibrium will shift to the left, which in turn will produce more calcium oxalate, that is kidney stones. Kidney stones are solid pieces of mass which are made up of tiny crystals and are found in the kidney of the body. It occurs when there is a constant buildup of certain substances in the kidney such as calcium. And most of the people don't realize that the formation of kidney stone has a direct and strong relationship with chemical equilibrium. Calcium oxalate is very common kidney stone and this is the reversible reaction of solid calcium oxalate and they form when oxalic acid is present. The oxalic acid in the body reacts with the calcium ions found in the kidney to form calcium oxalate solid in the kidney. Depending on the various factors that affect equilibrium and Lee-Satirius principle, the system will either shift towards the left or right, remain the same to get the equilibrium state. Different factors are concentration, pressure and volume. And depending on a person's lifestyle and their intake of food rich in calcium or oxalate, the equilibrium will tend to shift and the precipitate form in this reaction is kidney stone. If a person has high calcium intake, as the concentration of calcium ion increase, equilibrium will shift to the left, forming more calcium oxalate. Similarly, for oxalic acid, if the concentration of oxalic acid is increased in the body, the equilibrium will shift to the left and more kidney stones will form. Eating food rich in calcium or oxalate ions can shift the equilibrium to reactant or product side. Chemical equilibrium can help us to understand our body better. Chemical equilibrium is achieved when the rate of forward and reverse reaction is equal and they occur simultaneously, and rate of forward reaction must be equal to rate of reverse reaction, and the concentration of reactants and products after equilibrium remain constant with time, and chemical equilibrium are stable and dynamic in nature. To understand chemical equilibrium, first we have to know about reversible reaction. Reversible reaction occur in forward as well as reverse directions. The forward and reverse reactions are occurring in opposite directions. When the rates of two opposing reactions become equal, equilibrium is established, and at equilibrium no further change in the system is observed. It does not mean that the reaction has ceased, but a continuous cycle situation in which reactant gives product and products react to give original reactant, and such equilibrium are called dynamic equilibrium. And every chemical reaction has a tendency to attain equilibrium, but there are certain chemical reactions which remain unidirectional only, and such reactions are known as irreversible reaction. Equilibrium achieved in physical process is called physical equilibrium. There are different types of equilibrium like solid liquid equilibrium, liquid vapor equilibrium, solid gas equilibrium. Let us discuss one by one. Solid liquid equilibrium. When a pure solid substance is heated, it starts changing into liquid at a certain temperature. At this temperature, the solid and liquid states of the substance coexist under the given conditions of pressure. At melting point, the solid substance is in equilibrium with liquid state of the substance. And if heat energy is added to the mixture of solid and liquid at equilibrium, the solid is gradually changed into liquid. For example, ice and water in a perfectly insulated at a fixed temperature and pressure. Temperature as well as mass of ice and water remains constant, and actually it represents dynamic equilibrium between ice and water. Since there is no change in mass of ice and water, the number of molecules going from ice into water is equal to the number of molecules of water going into the ice. And at equilibrium, rate of melting is equal to rate of freezing. Another example of a physical equilibrium is liquid vapor equilibrium. When a small amount of water is taken in a evacuated vessel at room temperature, it starts evaporating. And at equilibrium, or pressure is built up gradually within the vessel due to the formation of water vapors, and this process continues for some time, and after attaining or at the equilibrium, the number of molecules entering the gas phase at any time is equal to the number of molecules returning to the liquid phase. And after some time, it is observed that pressure becomes constant. That indicates that no more water is evaporating, although liquid water is still present there. This indicates that a state of equilibrium has been attained between water and water vapor. Next is solid vapor equilibrium. In this case, solid undergoes sublimation at room temperature. A solid vapor equilibrium exists when such a solid is enclosed in closed vessel. When solid iodine sublimes to give iodine vapor and vapor condenses to form solid iodine, the intensity of color increases for some time and then becomes constant. At this stage, vapors of liquid are in dynamic equilibrium with solid iodine. Another example of solid vapor equilibriums are naphthalene, camphor, and ammonium chloride. Characteristics of equilibrium. At equilibrium, the measurable properties of the system becomes constant, and there is a dynamic balance between the two opposite processes. Equilibrium is achieved only in system which cannot gain matter from the surroundings or lose matter to the surroundings. In next video, we will discuss about equilibrium in chemical processes. Thank you.